horizontally launched projectile problems. In this case, we're going to be given information to solve for the vertical distance an object is above the ground when it's released and moves as a projectile. The data we need to calculate the vertical distance. First, we need to know what the horizontal velocity of the projectile is. And we also need to know the horizontal distance that the projectile is going to move. We're going to use that data to calculate the time it takes for the projectile to hit the ground. And we can use time equals our horizontal distance divided by our horizontal velocity. Once we know the time it takes for the projectile to hit the ground, we'll be able to calculate the horizontal distance, or the height at which that projectile was launched. And we'll do that by using our vertical distance equation. Vertical distance equals 1/2 gt squared. So here's your problem. A plane flies at 100 meters per second. It drops a canister of fire retardant onto a brush fire below. If the plane needs to drop the canister 450 meters before it flies over the fire in order to hit the target, how high is the plane above the ground? So first, let's draw a diagram of the situation. So we have our plane. We'll make our little wings. Okay, and it tells us that the plane is flying with a vertical or horizontal velocity of 100 meters per second. If it drops that canister of flame retardant, that canister will also be moving at 100 meters per second in the horizontal direction. But then gravity will start to act on it, and it'll move in a projectile direction before it hits the ground. So let's say that our fire is here. We know that our horizontal distance is 450 meters. We're trying to calculate the vertical distance. Okay, so if we think about this, let's just write down our variables that we have. The horizontal velocity is 100 meters per second. The horizontal distance is 450 meters, and we're trying to calculate the vertical distance. We know that our vertical distance equation is 1/2 gt squared. But the problem with this equation is that we need to know the time in order to calculate the vertical distance. And we don't have the time. So we're going to have to calculate time first, and then we'll be able to calculate our vertical distance. So time equals our horizontal distance divided by our horizontal velocity. So we'll plug in 450 meters for our horizontal distance. We'll plug in 100 meters per second for our horizontal velocity, and that's going to give us 4.5 seconds. That means that if we were to drop that fire-resistant canister at a velocity of 100 meters per second, it will take 4.5 seconds for it to hit the ground. Now we can calculate that vertical distance. We've got 1/2 gt squared as our equation. Now we know t, so we'll plug in 10 meters per second squared for our g value. We'll plug in 4.5 seconds for our t value, which we're going to need to square. So then we'll take 4.5 squared, multiply it by 10, and divide it by 2, and our dV value will be 101.25 meters. So if we have a plane that's moving 100 meters per second horizontally, and it drops a container which takes 4.5 seconds to hit the ground, it must have been 101.25 meters above the ground when it was initially dropped.